Good morning, everyone. This is B. Ramarao from Government Polytechnic, Station Ganpur. Today we discuss topic Lewis acid base theory. Lewis acid base theory. This topic belongs to first year diploma student for first year common syllabus for all branches. Topic Lewis acid base theory. Lewis acid base theory. Objectives. After the end of this period, you would be able to understand the Lewis theory of acids and bases. Understand the Lewis theory of acids and bases. Last class we discussed about Bronsted-Lowry acid-base theory and Arrhenius acid-base theory. Bronsted-Lowry acid-base theory and Arrhenius acid-base theory. We discuss what is acid, what is base. Now, today we discuss about Lewis acid-base theory. Lewis acid-base theory. Understand the Lewis theory of acids and bases. Lewis theory of acids and bases. In this hour we discuss about what is Lewis acid, what is Lewis base, what is neutralization between Lewis acids and bases, how do formation of bonding between Lewis acid and bases, and types of acids and bases, types of Lewis acids and bases. Finally, we discuss limitations of Lewis acid base theory. Limitations of Lewis acid base theory. Lewis theory. Lewis acid. Lewis acid. Lewis acid is substance which can accept pair of electrons. A substance which can accept pair of electrons are called Lewis acids. According to Arrhenius theory, what is an acid? The substance dissociated in aqueous solution, it gives H plus ions, are called Arrhenius acids. The substance dissociated in aqueous solution and give H plus ions are called Arrhenius acid. According to Bronsted-Lowry theory, what is an acid? The substance which donate to proton to other substance is called Bronsted-Lowry and acid. Bronsted-Lowry and acid. Now here, the substance which can accept a pair of electrons. A pair of electron acceptor is called Lewis acid. Lewis acid. This Lewis acid theory was proposed by Lewis theory in 1923. It was proposed in 1923, a new concept of acids and bases based upon the electronic theory of valency. Electronic theory of valency. He attributed the properties of acids and bases to the electronic structure of the substance. According to this theory, a chemical species that can accept a pair of electrons and form coordinate covalent bond is called Lewis acid. What is acid? According to Lewis theory, a substance that can accept an electron pair to form coordinate covalent bond. What is coordinate covalent bond? A bond formed between two molecules or atoms, pairing of electrons contributed by one of the bonding atom or molecule is called coordinate covalent bond. In this bond, one is electron pair donor and the other one is electron pair acceptor. Which one is electron pair acceptor in that reaction is called Lewis acid. Like example, Lewis acids H plus ion, Na plus ion, boron trifluoride BF3, zinc chloride ZnCl2, aluminum trichloride AlCl3, ferric chloride FeCl3, so on. What is acid? A substance that can accept an electron pair. Accept electron pair to form coordinate covalent bond is called Lewis acid. Electron pair acceptor is called Lewis acid. What is Lewis acid? Is substance which can accept a pair of electrons is called Lewis acid. Like H plus, Na plus, Mg plus 2, BF3, ZnCl2, AlCl3, FeCl3. These compounds act as Lewis acids. What is Lewis base? Lewis base is a substance which can donate a pair of electrons. Electron pair donor is called Lewis base. A chemical species that can donate a pair of electrons and form coordinate covalent bond is called Lewis base. Lewis bases. What is base? A substance that can donate pair of electrons to form coordinate covalent bond with acid is called base. A substance that can donate pair of electrons to form coordinate covalent bond with acid is called base. Electron pair donor is called Lewis base. Lewis base is substance which can donate a pair of electrons is called Lewis bases. Like example, OH minus Cn minus OH minus Cn minus F minus Cl minus NH2 minus H2O NH3. These all are Lewis bases. What is base? A substance that can donate pair of electrons to form coordinate covalent bond is called Lewis base. Electron pair donor is called Lewis base. Like OH minus, Cn minus, F minus, Cl minus, NH2 minus, H2O, NH3. Lewis base. Thus, Lewis acid is an electron pair acceptor. Electron pair acceptor or electrophile. And Lewis base is electron pair donor or nucleophile. One is electrophile, electron pair acceptor is called electrophile, electron pair donor is called nucleophile. The electron pair sharing between two atoms, one is electron pair donor, another one is electron pair acceptor. Which one is electron pair acceptor in that reaction is called Lewis acid. Which one is electron pair donate to the another substance in that reaction is called Lewis base. One is acid, the substance which can accept a pair of electrons. A substance which can donate a pair of electrons is called Lewis base. Lewis acid is an electron pair acceptor or electrophile, and Lewis base is an electron pair donor or nucleophile. See here, reaction between ammonia and boron trifluoride. Ammonia and boron trifluoride. This one is one of the neutralization reaction between acid and base. What is Lewis neutralization? The formation of coordinate covalent bond between acid and base is called Lewis neutralization. The formation of coordinate covalent bond between acid and base is called Lewis neutralization. The formation of coordinate covalent bond between acid and base is called Lewis neutralization. Formation of coordinate covalent bond between acid and base is called neutralization. Formation of ammonia and boron trifluoride. Ammonia and boron trifluoride. See here, ammonia contains one lone pair of electrons on central atom of nitrogen. In ammonia molecule have one nitrogen and three hydrogen atoms. The nitrogen and hydrogen form a covalent bond between N and H bond. In ammonia present on central atom of nitrogen have one lone pair of electrons. And boron trifluoride. In this molecule, one boron atom, 3 fluorine atom. On central atom of boron present one empty orbital on boron. In ammonia present one lone pair of electrons. Boron trifluoride present one empty orbital. Ammonia donates one lone pair of electrons to boron trifluoride to form coordinate covalent bond between ammonia and boron trifluoride. See here, ammonia contains one lone pair of electrons. Boron trifluoride contains electron deficient, that is one empty orbital. Ammonia donate one lone pair of electrons to boron trifluoride to form coordinate covalent bond between ammonia and boron trifluoride. In this reaction, ammonia electron pair donor, so this electron pair of the molecule or the substance is called Lewis base. In this reaction, electron pair accept from ammonia to boron trifluoride. So, boron trifluoride is electron pair acceptor in this reaction. So, boron trifluoride act as Lewis acid. Ammonia Lewis base, boron trifluoride Lewis acid. Then pair of electrons transfer from ammonia to boron trifluoride. These two electrons belong to nitrogen atom and also belongs to boron atom. Then both molecules get octet electronic configuration in its valency shell. Then ammonia get stable electronic configuration and also boron trifluoride also get 8 electronic configuration in its valency shell. Then ammonia and boron trifluoride to form coordinate covalent bond. What is coordinate covalent bond? A bond formed between the atoms bonded electrons contributed by one of the molecule is called coordinate covalent bond. So here ammonia base, boron trifluoride acid. Then these two electrons transfer from ammonia to boron trifluoride, then form a new bond between ammonia and boron trifluoride. Then ammonia and boron trifluoride form a coordinate covalent bond. See here, formation of ammonium ion. Formation of ammonium ion. This ammonium ion formed between ammonia and hydrogen ion. Ammonia and hydrogen ion. Ammonia contains one lone pair on central atom of nitrogen and hydrogen ion contains electron deficient molecule that contains one empty orbital on central atom of hydrogen. Ammonia donates one lone pair to hydrogen ion to form coordinate covalent bond between ammonia and hydrogen ion. Ammonia contains one lone pair on central atom of nitrogen. See here NH3 present one pair of electron on nitrogen atom and hydrogen ion contains one empty orbital. Ammonia donate one lone pair to hydrogen ion to form coordinate covalent bond between ammonia and hydrogen ion. Then these two electrons transfer between nitrogen to hydrogen ion. Then both molecules get stable electronic configuration in its valence. Then ammonia get octet configuration in its valency, then it is stable. Hydrogen get nearest inert gas helium configuration, 1s2 configuration. Then both get stable electronic configuration in this transfer of nitrogen to hydrogen ion. In this reaction, pair of electrons donate to hydrogen ion is called Lewis base. Ammonia acts as electron pair donor. Hydrogen ion in this reaction, electron pair accept from ammonia. These molecule act as electron pair acceptor. This electron pair acceptor is called Lewis acid. Then pair of electrons transfer between nitrogen to hydrogen ion, then form a new bond between nitrogen to hydrogen ion. See here, pair of electrons transfer between nitrogen to hydrogen ion. Then form a new bond between nitrogen and hydrogen bond. Formation of coordinate covalent bond between ammonia and hydrogen ion. Now, boron tetrafluoride, boron trifluoride contains one empty orbital on central atom. Fluoride ion contains one lone pair on central atom of fluorine, and boron trifluoride contains one empty orbital on central atom of boron. Fluoride ion, one lone pair, donate to boron trifluoride to form coordinate covalent bond between boron trifluoride and fluoride ion. So in this molecule, boron trifluoride electron pair acceptor is called Lewis acid. Fluoride ion in this reaction, electron pair donor. Electron pair donor is called Lewis base. Electron pair acceptor is called Lewis acid. Then form boron tetrafluoride. Then one pair of electrons transfer between fluorine to boron trifluoride. Then both molecules get stable electronic configuration in its valency shell. So here boron trifluoride get octet configuration in its valency, and also fluorine get octet configuration in its valency shell. Then both molecules get stable electronic configuration by the transfer of pair of electrons from fluorine to boron trifluoride. So in this reaction, boron trifluoride is act as electron pair acceptor. This electron pair acceptor is called Lewis acid. Fluoride ion electron pair donor. This electron pair donor is called Lewis base. This acid and base between transfer of pair of electrons. How do you transfer? Transfer of pair of electrons between boron to fluoride ion. Then form coordinate covalent bond between boron trifluoride and fluorine. This coordinate covalent bond is denoted as a arrow mark from donor to acceptor. The following species can act as Lewis acids. Lewis acids. What is Lewis acid? A substance that can accept and pair of electrons to form coordinate covalent bond is called acid. Electron pair acceptor is called Lewis acid. Types of Lewis acids. Types of Lewis acids. Molecule in which the central atom has incomplete octet. Compound in which central atom has incomplete octet, that is, electron deficient molecules all are Lewis acids. Electron deficient molecules are Lewis acids. Like example, boron trichloride, boron trifluoride, aluminum trichloride, ferric trichloride. These all are electron deficient molecules. It presents less than 8 electrons on central atom. These molecules are called electron deficient molecules. Molecule in which the central atom has incomplete octet. Less than 8 electron molecules are called incomplete octet molecules. These are also called electron deficient molecules. Like boron trifluoride, boron trichloride, aluminum trichloride, ferric chloride, ferrous chloride. These all are less electrons in the central atom of molecule. Those molecules act as Lewis acids. Lewis acids. Example, boron trifluoride, boron trichloride, aluminum trichloride, magnesium chloride, beryllium chloride. These all are Lewis acids. Electron deficient molecules. It presents less than 8 electron on central atom. Boron trifluoride, BF3. On central atom, boron presents only 6 electrons. It has less than 2 electrons to octet configuration. Then it is act as electron pair acceptor. Boron trifluoride. Boron trichloride, it is also present only 6 electrons on central atom of boron. It has less than 2 electrons on central atom of boron to octet configuration. Aluminum trichloride, it has also 6 electrons. Magnesium dichloride, it presents only 4 electrons in central atom of magnesium. It requires 4 more electrons to get nearest inert gas configuration. Beryllium chloride, it also presents only 4 electrons. It requires 4 more electrons to get stable electronic configuration. So these all are Lewis acids. A simple cations are Lewis acids. Simple cations. What is cations? The positive charged particles are called cations. Like example, H plus, Ag plus, Cu plus 2, Fe plus 3, etc. Simple cations are Lewis acids. First one is electron deficient molecules. Now cations. Na plus, K plus, Ca plus 2 have very little tendency accept electrons. So these all are electron deficient molecules. Contains like H plus, Ag plus, Cu plus 2, Fe plus 3 have greater tendency to accept electrons. So these ions act as Lewis acids. Molecule in which the central atom has empty d orbital. Compound in which central atom has available d orbital and can expand their octet. Compound in which central atom has available d orbitals and can expand their octet. SiF4, silicon tetrafluoride, SF4, SnCl2. So these all are available d orbital on central atom. These molecules act as Lewis acids. Example, SiX4, X means any halogen, fluorine, chlorine, bromine, iodine. GeX4, SnX4, PX3, PF3, SF4. These all are central atom as empty d orbital. Compound in which central atom has available d orbital and can expand their octet configuration. And it is expand their octet configuration. Molecules are called Lewis acids. Now, molecule having a multiple bond between atoms of dissimilar electronegativity are called Lewis acids. Molecules containing double bonds between dissimilar atoms like CO2, SO2, NO2. These all are dissimilar atoms between double bond. Molecule containing double bond between dissimilar atoms. Molecule having a multiple bond between atoms of dissimilar electronegativity. Like example CO2, SO2, NO2, so on. For example, CO2, SO2, SO3, NO2, so on. CO2. C double bond O, double bond O. OH minus react together, then form C single bond minus C double bond OH. C single bond minus and C OH. Then here CO2 act as Lewis acid, OH minus Lewis base. This base pair of electrons donate to CO2. These pair of electrons donate to CO2, then form a new bond between OH and O. OHO pair of electrons transfer between OHO, then form COOH bond. Then pair of electrons transfer from OH minus to OHO bond. Then pair of electrons transfer between carbon and oxygen. Then one oxygen get negative charge. So then form CO2 and OH minus. In this reaction, CO2 act as Lewis acid, OH minus Lewis base. Lewis acids. What is Lewis acids? First one is incompleted octet molecules, electron deficient molecules, boron trichloride, boron trifluoride. These all are electron deficient molecule act as Lewis acids. Lewis acids are all cations are Lewis acids, H plus, Ag plus, so on. Compound in which central atom has available d orbitals, SiF4, SF4. These all are Lewis acids. The molecule containing double bond between dissimilar atoms, CO2, SO2, NO2, so on. Now, types of Lewis bases. Types of Lewis bases. First one is all anions are Lewis bases. What is anion? The atom having negative charge are called anions. These anions are Lewis bases like OH minus, Cl minus, Cl minus, F minus, NH2 minus, so on. These all are Lewis bases like Cl minus, F minus, OH minus, Cl minus, O minus 2, SO4 minus 2. These all are Lewis bases. All anions are Lewis bases. Cl minus, F minus, OH minus, Cl minus, O minus 2, SO4 minus 2. Molecule containing one or more lone pair of electrons. Molecule containing one or more lone pair of electrons on central atom. Molecule containing one or more lone pair of electron on central atom like NH3, H2O, RNH2, ROH, so on. H2O, NH3, PH3, ROH, or NH2. These all are containing one lone pair of electron on central atom of nitrogen and oxygen. This pair of electron donor is called Lewis bases. The molecule containing one or more lone pairs of electron on central atom are called Lewis bases like H2O, NH3, or NH2 or OH. H2O, NH3, PH3, ROH or NH2. The molecule having multiple bond between carbon atoms. The molecule having multiple bond between carbon atoms. Molecule containing multiple bond between carbon atom molecules are C2H4, ethylene, C2H2, acetylene. C2H4, C2H2, C3H6. So C2H4, ethylene, C2H2, acetylene, C3H6, propene. These molecule containing pair of electrons, it is act as Lewis bases. All anions are Lewis bases Cl minus, F minus, OH minus, Cn minus, O minus 2, SO4 minus 2. Molecule containing one or more lone pair of electrons H2O, NH3, PH3, ROH or NH2, so on. Molecule having multiple bond between carbon atoms C2H4, C2H2, C3H6. Limitations. This theory failed to explain strength of acids and bases. This theory failed to explain strength of acids and bases. Acid-base reaction are very fast, but Lewis acid-base reaction are slow reaction. He failed to explain neutralization reaction between acid and base. HCl, H2SO4 cannot form coordinate covalent bond. Cannot form coordinate covalent bond. These are limitations. This theory failed to explain strength of acids and bases. Acid-base reaction are very fast, but Lewis acid-base reaction very slow. He failed to explain neutralization reaction. HCl, H2SO4 cannot form coordinate covalent bond. This theory could not explain strength of acids and bases. All neutralization reactions do not involve formation of coordinate covalent bond. Coordinate covalent bond is not formed when HCl react with NaOH. Acid-base reactions are very fast, but formation of coordinate covalent bond is very slow. According to this theory, HCl, H2SO4 cannot form coordinate covalent bond. It could not explain its catalyst ability of H plus ion. These are limitations. Summary: Lewis theory states that acids are electron pair acceptor, bases are electron pair donor. Electron pair acceptor acid, electron pair donor base. Lewis acid bases form coordinate covalent bond. What is coordinate covalent bond? A bond formed between atoms or molecule bonded electron contributed by one of the involving atom or molecule is called coordinate covalent bond. Cations are Lewis acids, anions are Lewis bases. Now, quiz questions. What is Lewis acid? What is Lewis acid? A. NH3, B. H2O, C. PH3, D. BF3. What is Lewis acid? What is acid? Electron pair acceptor is called Lewis acid. A substance that can accept pair of electrons. Ammonia contains one pair of electrons on central atom of nitrogen. H2 also present one pair of electrons on central atom of oxygen. PH3 contains one pair of electrons on central atom. But here boron trifluoride present one empty orbital on central atom of boron. This empty orbital pair of electron acceptor is called Lewis acid. So what is Lewis acid? A. NH3, B. H2O, C. PH3, D. Boron trifluoride. Answer D. Boron trifluoride. Boron trifluoride is answer. Which is Lewis base? A. Boron trifluoride, B. NH3, C. Boron trichloride, D. HCl. What is Lewis base? Electron pair donor is called Lewis base. Boron trifluoride contains one empty orbital. Boron trichloride contains one empty orbital. HCl does not act as Lewis acid or base. Ammonia contains one pair of electron on central atom. This electron pair donor is called Lewis base. What is Lewis base? A. Boron trifluoride, B. NH3, C. PCl3, D. HCl. Answer B. NH3. Boron trifluoride, boron trichloride, HCl does not act Lewis base. Which ion is Lewis acid? Cl minus ion, B. Mg plus 2 ion, C. O minus 2, D. HCl. Which ions? All cations are Lewis acid. What is cation? Positive charged particle is called cation. Cl minus have negative charge, O minus 2 negative charge, HCl they have no charge. Now here Mg plus 2 present positive charge. The positive charged particle of Mg plus 2 is act as Lewis acid. Answer B. Frequently asked about these topic questions. State and explain Lewis theory of acids and bases. State and explain Lewis theory of acids and bases. Second one, all Lewis bases are branched Lowry bases. Explain with an example. All Lewis base. What is Lewis base? Electron pair donor. What is Bronsted-Lowry base? Proton acceptor is called Bronsted-Lowry base. A Lewis acid need not be to Bronsted-Lowry acid. Justify this statement with an example. Classify the solvent as per Bronsted-Lowry theory. Thank you once again.